Okay, so this is question number 34 from the book Pathfinder, chapter kinematics, subsection check your understanding. Two cars are moving at constant speeds, one on a circular path radius r and the other on a straight road. Magnitude v of the velocity of one car relative to the other has been recorded at regular intervals of time, and data thus obtained is represented in a graph as shown in the figure. Calculate speeds of both the cars relative to the ground, and this is the graph shown here. Okay, let's see the solution. So this is the graph shown. This is a graph of relative velocity versus time graph. Suppose a car moves along this straight line with a velocity v1, call it, and the car is moving along the circle, and this speed suppose is v2. When that car which is moving along the circle is at this position, these two velocities, the velocities of both cars are there parallel now and in the same direction. At this instant, the relative velocity will be minimum. When the two cars happen to have velocities in the same direction, the relative velocity will be the difference of these two, and it will be a minimum velocity in magnitude. And see the graph, the minimum velocity is 0 at this point A. So we can say that v1 and v2, they are equal in magnitude, and call it v. Okay, now the cars moving along the circle is at this position, suppose at a general position, at a theta position, and it's having a speed v. Now find the relative velocity of this car moving along the circle with respect to the car moving along this straight road. So we'll have to draw a diagram like this. So this v is in the same direction. This v1 is drawn in opposite direction because it has to be subtracted, because we have taken the car moving along this straight road as observer. And if you find the resultant of these two v's, which is the relative velocity, it happens to be like this 2v cos theta by 2. So this relative velocity is a cos function, and if we differentiate this, you can check the differentiation. D theta by dt is simply omega, the angular speed. And what I am doing, I am just omitting this minus sign, and I am just putting a mod here. So if you find mod of this dy dt of vr, so this minus sign can then be removed like this. So this is the modulus. From here we can write omega as v by r as it happens in circular motion. So the formula becomes like this. So from here, if you find v, the value of v, it will come out equal to this. Now we have to put all these values for any point on this graph, any suitable point on the graph, and all these values for that point will give the same v. Okay, so the most convenient point is point A. At this point A, cos theta by 2 is 0 because relative velocity is 0. And when cos theta by 2 is 0, sin theta by 2 will be equal to 1. Capital R is given in the question. Now we have to find the slope of VT graph. So for that, draw a tangent at point A. Draw a small triangle here, and in this triangle the height is you can verify it's 10, while the base is 5. So this will be 10 over 5. Capital R is given as 200, and on solving it will give the value of 20. So good question. See, maximum velocity is 40, that you can assume, but it's not given in the question. Someone can argue, why not use this maximum velocity is 40? So that will give v1 plus v2 as 40. But that 40 is not given in the graph. So we cannot say for surety that maximum speed goes to 40. One thing. The second thing, the graph shown is for 50 seconds. We are not sure that it is a time period, because exactly the same graph would repeat after this. We are not sure about that. So we cannot say that 50 seconds is the time period, because from time period as well we can find the value of v, but that is not given exactly in the graph. So the only method left is to use this slope. Okay. So it's a good question. Hope you enjoyed it. Thank you.